Yo, hello. I'm SolarLuna. I'm an independent game developer. I'm the creator of Masterplan. I'm the creator of Tetra 3D. I'm the creator of that little adventure game. that I was working on. Well, I am working on. That's what we're going to be working on today, actually. Yeah, so hi. Sorry that I missed Wednesday's stream. I was super busy. Completely forgot to cancel the stream. But now we're back. And welcome. Yeah. So first things first, I'm going to start off with some very minor tweaks to Tetra 3D with some collision checking stuff. Something that actually, let me get some music going before I start talking. That's too loud. Hopefully it's not. No. Okay. So let me get something contemplative. So yeah, previously what this is just let me see here. And then we could probably do like, yeah, I guess we could close Discord. Yeah, so oh, actually, before we do, hold on. Hold up. Let me do something real quick. Okay. So, yeah, last time, oh, okay, yeah, this is what I was talking about. So basically, the way that my ray testing and collision checking code works is that previously these functions would return a boolean if they worked, and if you wanted to get more information, you would have to use the ray test options or collision test options struct that allows you to specify a callback to be called for each collision. Now I'm changing it so that it basically will return the first hit. Yeah, the first hit. So that way you can use the function like a boolean check. You could also use it to get the first strike if you don't care about the others, which you may not in a lot of cases. Like for example, if you're touching a death block and you don't really need to know which block, like you don't need to distinguish between the blocks. Whichever one hits first is probably fine. And an incident death, hazard, or a ray test, if you're like checking for ground, whichever one hits first is fine. So that's a nice little quality of life improvement. Yeah, maybe I should do, well, no, because that's not really necessary, huh? Well, then why do I do this? Why not do it like that? Well, how did the ray test work? Oh, right. I see. Okay, I guess it's fine either way. Yeah. So anyway, yeah, we're making this little quality of life thing, and then we're gonna do something a little unusual. So I think this should work. Let's see. Ah, that's why. Right, okay. Did we do a unit? Let's try this real quick. Yeah, no. There's something I gotta work on with this movement. Like if you move up, the object slides around. I should fix that. Actually, maybe I can fix that. I have a general idea of what might be causing it. Let's see. Yeah, that's what I need to do. Okay. Hold up. Well, wait, can I just do... What if I just did... like this? Wow, that's crazy how it's immediately better. Okay. Okay, well, maybe not immediately. Maybe not immediately better. Okay, but this is good. Like that works really well. No more sliding. This is an issue. So this is happening because we're moving into basically two different faces. Let me see if I can draw it out. I might be able to use grease pencil here. The idea is, let's see. Okay, so I think that, hold on. Okay, so well, all right. So the idea is that basically if we're moving into this core, if we're moving like this into this wall creates a vector going out like that. If we move into this wall, then it comes out like this, right? If we're moving into both of these, it basically says, well, which one is the strongest, and then returns that one. Really, we want to average those two results. So it's kind of like a max MTV, but with an average MTV's vibes. So I guess what we want to do is maybe we like this. I feel like I tried this, but let's try it again, because this was the best movement I've seen so far out of this physics system. Yeah, no, it's still sliding. Let's see. So MTV is vector. Yeah, just dist. And we use this. Okay. Let's see. I feel like I'm on the right track. So why is it giving X movement? That works really well. So I think what we need to do there's a couple things we could do. One is to do another pass. So basically, after we move it out one time, it does it again and keeps doing it until there's no more MTVs found. Let's see. Smooth it out like that. It will smooth it out like that. We can average them. We could try averaging them, but why does average not give the same result as max? Town Eater says, working on some environmental design? No, working on some physics stuff, actually. Well, not physics, but just like collision resolution stuff. Excuse me. Always tricky. Yeah, I don't need to, but this is something that I'm doing just because, like, if we don't do this, well, basically this is how I usually do collision like resolution, or this is how I am doing it currently. You can see that when my capsule here walks into the ramp, it's shifting to the left or right. Didn't used to be that bad, did it? I guess it was, because I don't see any. I didn't change the code. I'm not sure what why it's tripping out now. Let's see. But this gives a little bit of a better result. Weird. That'll be an interesting one to fix. Yeah. This gives a much better result. But the corners are bad. Corners are bad. Corners are bad. What can we do about the corners? We can average them out. So why does averaging not do what it feels like it should? I mean, well, there's a couple of things. There's a couple of issues here. If we take a look at even just something simple like this collision setup. The capsule can squeeze between the two objects. I kind of like that. I kind of like that ability, but I don't think it should exist all the time. I think that's very human, very organic to be able to squeeze between things. But for the purposes of video games, it probably shouldn't be able to do that, unless. But I mean, yeah, unless. But I mean, like it's kind of an interesting problem, because basically what it's doing is it's solving this collision and then this collision, and it basically is pushing into the sphere or into the cylinder rather than basically combining them to make a stay out of both of us vector, which would be going in this direction. Instead, they're both pushing like this, which allows the capsule to overcome that movement, I think. So we can try averaging out the vectors. Oh, maybe it should. don't think you can average them out and then go with the smallest vector, right? No, it's got to be the biggest vector. Or is it just adding them? Is it just adding them together? Let me see. So if you have a wall like this and a wall like this, and you have a character, an object, a cylinder, whatever, it's like this, right? So it's way more into the top wall than it is the left wall. It has to move out. That means that it's going to move out by this distance. Basically from this, well, let me use orange. From this point out, or from this point out like that, right? That's going to be the move out vector. And it's also going to move from this point, well, from this point this way. That's going to be the right vector. So that it will sit at the corner. Now, we could, if we just combine them, it will move out this far and to the right that far, and I guess that's it. So maybe that's all we got to do is just add them together. Well, no, because if you have multiple intersections, well, let's see. I think this is not going to work though, because I think if you have multiple intersections, yeah, it's going to move out. Let's see. So we do have to average them out, because basically the issue is now a wall can be comprised of multiple faces like this, right? Multiple triangles, rather. This can be a triangle, and this can be a triangle. And they both say to move out a certain distance. Right? So like, if they both say to move out at a certain distance, and then this vector gets doubled, which is bad, of course, and that's what causes this shaking. That. Let's see. Can I just add it? Can I just... Let me see something. Check all the triangles for an object, and then average out all the collision positions to calculate your vector. Let's see. Maybe. Maybe. Let's see. Maybe we want the minimum MTV? I don't think we do, but let's try it. Okay, so there are multiple intersections. Let's see this one. Okay, so AABBs work fine. It's triangles that give the most problem. There's... let's see. I mean, I guess what we could do is maybe like, what if well, hold on, because I feel like I might be on the right track here. Inner normal. Okay, so there is a normal. It's y up. Okay, so it's colliding with this surface. Yeah, right. Uh, is it normal? Okay. I might be kind of getting an idea of this. I think what we might need to do, or what might work all right, is to go with this. Also, that reminds me to do something. Map. Something that might work is I'm thinking that we might be able to well, let me see. I feel like the normal might be the key to kind of like getting us a little bit more consistent results. Excuse me. Hello. Hi. Welcome to the stream. Let me change the music. I feel like the issue might be it might be related to the normal. Like, I think we might be able to get a consistent collision based off of the normal. Was that one of the songs from Urine? No, that was a remix of a song called Gray by Trampeak. Yeah, Tom Peak or Trampeak. He's like a kind of like a breakbeat ambient step kind of thing, dark ambient. But I can put on some Girin music next. Let's see. So I think what we want to do is make some sort of resolver that steps through the intersections, and as it moves the object back, it checks to see if it needs to move it on the other intersections, right? Like, if we look at this sequence just as an example, the first vector it moves on is on the z-axis, and you can see that the normal is basically away from the ramp, from the wall of the ramp, and the first vector is the same thing. It's moving backward away from the ramp, and then the third vector is basically a different vector caused by the upper side of the ramp. This triangle here, one of these triangles. So I think what I want to do is I may want to make something that allows you to provide, well, make something that allows you to step through the MTVs, and as it moves the object back, as it applies the MTVs, it checks to see if it needs to move the object any further on any other MTVs based off of the applied MTVs. So I think we don't want to, I mean, I guess we could just, Because as we move, let's go back. If we have a object like this white sphere, and it is here, when we move it back, we don't need to move it on any other axis because it's outside of the, like, no other collisions are necessary. You just run the checks until you encounter a collision, move it back, start your checks over, keep going until it doesn't move. I was thinking that, but I don't want to do that because that would require stepping through a triangle collision multiple times. I mean, what I guess I could do is I could step through only the triangles that triggered the collision in the first place and check only those. So you have triangle, you have an object, you check for collision against a mesh, triangle mesh. It says, okay, you are colliding with triangle 6, 7, and 9. 6, 7, and 8, we'll say. You move away from triangle 6 and then checks to see if you're in collision with 7 and 8, and then if not, you're good. But that would allow you to, like, that's not a perfect solution either, but at least that would not be overly complex. Like, it would allow you to reliably move through a space. Well, let's maybe think of it from a different perspective, because now that I'm thinking about it, maybe the answer is actually simpler if we kind of generalize it. Let's say we had a room that's shaped like this. This is one mesh. You know what? Let's say this is multiple. Well, I guess it doesn't matter. Yeah, let's say this is a room shaped like this. This is our object. When we walk into this space, into this crevice, it should detect that there's a triangle here that basically pushes our object in this direction. And there should be a triangle here that pushes our object in this direction. The end result should be essentially that we're pushed out like that. So that means that we're basically averaging out the MTVs. So then I guess maybe the question becomes, why does this push up? No. Well, where is the X movement coming from? Yeah, it is coming from that one that is not on the same normal. So maybe we should yeah, maybe the normal should be involved here. So let's check that out. BT capsule triangles. Let's see. Try center, capsule top. Okay, so this is the way this is working. Let's see. So we have a ramp that's shaped like this. We have a ball that's here. Should collide with the wall. Why would it collide with the top? Oh, because it's going into the wall because we're moving into it. Okay. Yeah. Okay. Yeah, I see. So what we can do is, yeah, maybe make a function on a collision. That basically because each intersection it has a triangle. So we should be, let's see, BT triangles, capsule triangles. Might be able to break this down to be just the triangle. It's a little tough. We want to be able to retest a capsule versus a triangle for collision. Yeah. So I think I think you were right. I think you were right. This is also how I think I did it with Resolve, but I think you're right that if we check for collision and we see that it's colliding with 3 surfaces, if the surfaces are organized by order of distance, which they are, when you move an object to avoid one, well, really, well, now that I think about it, the MTV should just be calculated dynamically. Can I do that? Delta is the sphere position substituted by the closest point on the triangle. If we know the triangle and we know the closest point on the capsule, then maybe we can get the MTV live. That's some math, but most of the math is from finding the triangle in the first place, I guess. So maybe that's the strategy. We check for collision, and if so, we're given a list of intersections. We then loop through each intersection and move it back according to the MTV. The MTV is not determined statically, it is determined dynamically. So you say intersection 1.mtv, a function call, and that gives you the MTV. Then you can say intersection 2.mtv, and it should basically recalculate it. They should all be calculated dynamically. Okay. So mag is the delta magnitude, delta being the difference between the sphere position, the closest point on the capsule to the closest point on the triangle. Hold on. Yeah. Okay. So let's try this. This is gonna get a little crazy. Okay. All right, so I think what we're gonna do, we're gonna go up here, we're gonna remove MTV entirely. By making it a function, it can be dynamic, which means it can change as we move the object in response to MTVs. So it has to, because we know the triangle, well, it has to know the kind of object that is making the intersection or making the collision. Because if it can know that, then it can know how to properly determine the MTV. MTV here, that's correct. These MTVs are fine because they're one time MTVs. This MTV is not, though. Transform no location. Delta is the sphere position minus the closest point on the triangle. Scale it by the sphere radius minus the magnitude. I see, to put it into collision. I just got a really ugly idea. Let's try it. Really ugly idea. I love trying ugly coding ideas. Yeah, this is disgusting, but maybe it's, oh, that's so stupid though. Cause all this stuff is not done live. Unless we made it live. No. Well, no. Well, no. What? Well, how stupid is this? We couldn't like reuse any of these variables. The idea that I had was basically, what if each intersection created a function that essentially calculates the MTV? So when we create an intersection, we create a function. We don't call a function. We don't store the value. We create a function that, when called, calculates the MTV. That is stupid, but also kind of ingenious. But the problem is that the variables, the arguments essentially that go into the function, wouldn't be dynamic, right? Like, we'd have no way of knowing. We would have to, let's see, like in this situation, transform no lock would have to be in the function. Delta would need to be in the function, which means sphere position needs to be in the function, which means inverted transform and sphere world position. So basically the entire thing needs to be in a function, which is bad because that means that we can't reuse any of these variables. Because when you call MTV, it needs to do all this. Right? We need to establish all these variables, do all this, put it into MTV. What if there's another way we can do this? Let's look back at this example. the object is here. The first MTV says to move it out like this. The second MTV says to move it out like, or I guess it would move it out, yeah, this far. The second MTV says to move it out like that. How do we do that? How do we do that? I guess we just subtract each subsequent MTV from the previous one, right? And then if they ever equal 0, then we're done. Why can't I do that? Isn't that the same as just adding them together? So the issue with this is we have one MTV that says you need to move 0.1 units out on the z-axis. Then we have another MTV that says you need to move 0.03 and 0.07 units out from the x and z-axis respectively. Okay, well if we move on the first MTV, then we don't need to move on the second. Let's try that. Let's see if that works. Well, but the x-axis could still be necessary. You could still need to move on the x-axis. How do we know we don't need to move on? What about taking the greatest value for each axis? No, because this, in this example, because basically, let's take a look at this situation. But imagine that this is like vertical, right? So this is like x and this is y. So this is up. So this is left and right, this is up. If the object is something like this, then it would trigger this MTV or this intersection on this triangle, this face, but also this one on the vertical face, vertical facing face. We don't want to take the greatest value for each axis because that's going to move this out, and then this is going to move it maybe up like that, and that's not right? We want to just move it out on the main axis, whichever is deepest. And you can say, okay, we'll just take the maximum. Well, that doesn't work because if you can imagine this is now looking down, if we're like this, then it's going to move either axis individually. It's not going to move out like that. It's going to move down or right like that. And so it's going to have this shaky like do. So we need some way to basically say, if we move it on one, retest it, but we don't want to have to retest it. Can we test a single triangle? But I don't want to have to. I mean, we can test a single triangle. I mean, that's fine. Do I want to make that function? I don't, though. I can't reuse like this function at all. That's the problem. In order to make it efficient, we have to reuse all of these variables for all of the triangles that we're testing. Well, what if we provided a triangle ID? So we can basically ask for a single triangle if necessary. Otherwise, we can just look, do them all at the same time. Okay. So let's say we had a single triangle that we could specify. How would that work? So you move the MTV and then you recall basically whichever function is required to determine if there's a collision with the provided triangle. but it might be multiple triangles, right? Let me see. On collision, is the average MTV for intersection. Each intersection can be with one triangle. So you move one MTV, and then you check the following triangles. Okay. All right, that might be what we do. And we only need to do it for triangles. For sphere, triangle, capsule triangle, AABB triangle. Okay, so something like this. So we provide the triangle that we want to test on. Okay, all right. So I think we're on the right. I think I'm on the right track. I think. This was a gonzo wonky idea, but I wish it could have worked because it was kind of fire. I like that kind of weird design in certain places. Okay, so I think the idea is we go down here to all these functions and basically provide another argument that says basically test only this triangle ID, where we say if triangle ID is equal to try ID. Oh, if only triangle ID is greater than or equal to 0, and only triangle ID is not equal to triangle ID, then we can return true. So basically, we skip all the triangles except for the one that we're interested in. Okay, so that's. I'm gonna make a note here. Only triangle ID allows us to perform subsequent tests. And then the idea is that basically when we perform the collision test, when we are looping through maybe we have another function instead of just on collision. We could also have like collision reapplication or something, like apply collision, apply on collision, so something that allows us to say like it would retest I'm genuinely like trying to figure out, because the problem now that I'm seeing, or I'm trying to understand, is like, let's say you have this kind of a situation where you have a ceiling and a floor, and you put a sphere here, right? So it moves up. It's just going to phase through the ceiling. But I guess it has to do something, right? Like, what else are you gonna do? Like, are you gonna just stall indefinitely? It has to go somewhere. Okay. Let's try this. Let's try this and see. Okay, so we have only triangle ID here. And there's only a few collision types, only 3, I think. We do that here as well. That up actually, so it's not. We're not assigning variables unnecessarily. And then we do the same thing. This is sphere. This is AABB. I'm not even gonna touch this one. I can't not touch this one. Let's see. B try index. Okay, wait. Maybe can I just retry the collision? So, I mean, I guess that would mean there's no MTV, right? Because, well, so you check to see if you're colliding with something. It gives you an MTV value. You move. Well, you check to see if you're colliding with something. It says these are the things you could be colliding with. And then for each time you move, well, okay. So you're colliding with a mesh. It has multiple intersections. How did I do this in Resolve? Let me take a look at that. Because I remember solving this exact. Okay, so you have possible intersections. You look to see basically what are some possible intersections. These are objects that, other objects that it could be colliding with. Then it checks to see if it's intersecting, and if it's not empty, then so if there is an intersection, it says you collided. So that's, it returns a bool. It says you collided, but then it also says if there's a callback, then run the callback. But it doesn't. Let me see. The intersection set has intersections. Okay. The MTV is for all the faces. Well, does it average them out? How does it do this? Consolidate hits together across multiple objects. Is that what it's? I mean, I guess that makes sense. That's the minimum translation vector. So then why did I try this and it didn't work here? Okay, I think I'm on the wrong track rather. I think fundamentally what changed? Oh, yeah, what changed? Uh, okay. So yeah, I think what I'm missing is that the MTV is supposed to be across multiple intersections. An individual intersection shouldn't have the minimum translation vector. That should be for the entire intersection set. Well, I don't know about that, but there should be MTV. Okay, so I think I'm on the right track. I think what I need to do is do this. And this is where I think we need to work on. Let's try this. Okay, so, and then we want to can we just like disregard triangles that aren't facing the object? I feel like we could, but the problem is that I don't know that that's the solution, right? Did we ever call this? We did. Okay. So let's try this and see how this looks. Okay, so now it's just that. Now it's gonna be just the wall. Yes. Normal. Okay, the MTV is still weird though. It's a give Y. Let's see. Okay, yeah. Why? Right. Okay. Okay, let's try this. This may not be solvable in my lifetime. Like, I'm not sure quite how to solve this, but let's try this. So for each intersection, you run a function. Oh, I don't have the... Okay, so we could do something like this. Let's see. Okay, I think that's all of them. Okay, sphere, sphere, sphere A, B, B, sphere, triangle. A, A, B, B, A, A, B, B, triangle. Triangle, triangle. And then capsule, triangle. Because capsule A, A, B, B is just sphere A, A, B, B. Okay. Okay. Wait. Oh, let's see. Okay, yeah. Let's see. Alright. Sphere, capsule. Okay, I think I'm on the right track, maybe. So if we have this information, we know what displacement was applied through this process, right? So Uh, this is crazy. This is crazy. I guess we don't need to know that the object's moved. Possible ban evader. You've been banned. Let's see. I'm on the right track, I think. Okay. So I'm thinking something like this. All right, so this is what I'm thinking. I'm thinking, and I think I'm kind of on the right track to a solution. Maybe not the best solution, but a solution. So the idea I have is basically this. Let's say this is a surface, and let's say this is a surface, right? Like that. Let's say we're something like this. We can make this slightly transparent, right? Yeah. We'll make it a little more transparent. So the idea I have is basically we move the sphere up. Like this is the MTV, right? That it says, okay, you need to move the sphere like this. Once you do that, the sphere will be here. This MTV will still exist. It will still say, you know, of course, what it does. But we can basically say, okay, well, this MTV would have the object move like this, maybe. But the magnitude of the first vector overlaps with the second. Like basically the dot product, I think, of the first vector and the second vector overlaps. Like basically we want to subtract from the subsequent NTVs the amount of movement applied from the current vector. So if MTV magnitude, well, so this is this guy. We want to know what overlap is there with the current MTV. And that should give us the amount. Excuse me. So, I mean, really, yeah, if we print out the dot and it's greater than 1, that might indicate that the MTV can be essentially erased. In which case, we may not need the starting positions, object's position. Well, we don't know how much forward how much it's moving through space. So for now, let's just see if we can tell this. Okay, so this is it. Let's see. Okay, so MTV. This one. You know what, let me see if I can simplify this a little bit to make it easier to tell if it's working or not. I don't know. Hold up. Let's start off just so I can understand what I'm looking at, because I feel like I might be kind of like cooking, but I need to see. Okay, so there's two intersections here. They're both normal facing away. but we see that there's some sliding going on. The first one moves. Oh, the first one moves to the left. That's a definite possibility I hadn't considered. Sliding, huh? The first one can move. Can we rerun the collision test? Well, maybe that's more so the issue. Why is there an X component at all? Maybe that is the issue. So there's a couple things we can do, because maybe this solution is a little bit overly complex. So let me think here. Yeah, there's an X component to this that doesn't need to be there. Even just looking at this as simple as possible, why does it slide on the x-axis? Yeah, why is there X at all? I mean, Hmm. 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 I didn't want this to be the whole stream. This is gonna be the whole stream, dude. Like this isn't intentional, but it's kind of important. Okay, that definitely is solid. Is that better than it used to be? Instead of it being the delta, should it be the normal instead? You're enjoying this, Town Eater? I'm glad to hear that. Okay, we're not getting that sliding. So there's a little sliding going on. That's basically caused by, it looks like, the delta of the... Well, let me see something. Yeah, at least you're enjoying. At least somebody's enjoying this. This is how it used to be. It used to be this bad. That tunneling is crazy, dude. So just going with the normal instead gives a much more consistent result when compounding the MTVs together, huh? Okay, that actually, yeah. Okay, so this is unaffected. It's not perfect, but it's a lot better. Okay, so let's see if that works. Then can we do the same thing for the BT capsule triangles? Or instead of being the delta, it's the normal. I'm not sure what that's all about. It's a lot better in all the other cases. That might be caused by the upper part, maybe. Okay. Well, if it's an improvement, it's an improvement. Let's see if it's an improvement. Now it is not an improvement. It's kind of funny how bad it is. Let's see. It's the average MTV. Let me see something. Man, this is not working, and I'm not sure what I need to do. Alright, well, that's life. It doesn't always work out the way you want, I guess. At least it's solid, even if it's not ideal and objects can slide around and stuff. At least, like, it works. Why does it do that? Whatever. I can't figure it out. Well, at least this is an improvement. But what I wanted to do in this stream was, I guess this will have to wait till next stream or another stream. Basically, I was trying to work on moving from JavaScript to Go using Yaigi for, well, actually, hold on, let me check out something real quick. Well, yeah, that's what I was going to do, is go from JavaScript to Go for go from JavaScript to Go for go from JavaScript to Go for scripting, for the scripting layer. Basically using Yaigi. So that's an idea. It feels like it should be faster, and so it's something to think about. But at the same time, it's not something that well, it's something that I'm working on. Basically, moving things over to see how it works, how it performs. Is it equal in speed? Is it faster? According to my calculations, it should be significantly faster. Maybe primarily because I'm doing a lot of Go function calls. Maybe because I feel like I've seen Goja versus Yaigi benchmarks, and I feel like Yaigi was the slower of the two, but maybe that was old in data. Maybe that was just benchmarking pure function call speed as opposed to interoperability between Go and Yaigi and Go and Goja. It feels like Yaigi should have better interoperability because there's the types that are implemented in Go are implemented in the scripting layer, right? So it's like, oh, this is a function, it needs to be a function in Go, as opposed to JavaScript, where it's like it's both dynamic, where you have to do more reflecting on that side, but also a function can take a variable amount of arguments in JavaScript versus a fixed amount of arguments in Go. So it feels like it should be faster with Go, because all the things that you're making in the scripting layer should be backed by the same type in Go, as opposed to Goja, where obviously it could be dynamic, but it could also be where there's no direct analogs, right? So I don't know, I feel like it should be faster. The little test I did indicates that it's faster. I'll show that test here if I have it. Oh, did I? Let me see. Here we go. So this is the Yaigi version. You can see logic execution is 2 to 3 milliseconds. Somewhere in that range. Well, maybe 3 milliseconds, 3 to 4 in that range. And then the JavaScript version that should be doing basically the exact same thing is here on the left. And you can see the logic execution is 6 to 7 milliseconds. So it should be twice as fast, which is fantastic. But when I started actually building it out, it didn't feel like I was getting the same results in terms of speed. But basically the way that I'm doing this, I think I'm doing it correctly. This is the script in JavaScript, which basically just says, set the position of the camera to be the camera's position, but lerping toward a target vector. 10% every frame. Do that 1,000 times per frame. And so this is the JavaScript script, and then the Golang version should be the exact same thing, and it should be this, where it's the same thing, right? Where we're getting the node, we're getting the target, or creating a target vector, and then for 1,000 times per frame, we're setting the position to be the position lerping toward the target by 10%. So it should be basically the same. And we're getting much better speeds, but like I said, once I started actually building it out, it didn't feel like I was getting good speeds. It felt like it was gonna be about the same. But looking at this, it feels like there's no way it could be the same, right? Like, this is doing a lot of Go, a lot of function calls, but it's also doing a lot of Go interoperability calls. Set world position vec, world position, and the target vector are all types implemented in Go. They're not implemented in JavaScript. Tetra 3D inode is of course Tetra 3D. Vector 3 is of course Tetra 3D as native types, right? Native Go types. So it feels like this should be about as best case scenario, and using a whole bunch of Go interoperability calls. So I'm not sure why it may not be as good in terms of frames, in terms of logic execution once I actually started to build it out. So we'll see. I'll see what I can do about it. But I guess this is fine. We'll stop here. It's been a couple hours. I wish I did more, but it doesn't always work out the way that you want, right? So anyway, thank you very much for watching. I've been SolarLoon. It's been real. I'll keep working on this as usual, and other stuff. Master Plan. That new update is coming out soon. I'm not forgetting about it. Yeah, thanks for watching, and I'll catch you guys on the flip side next time. Thanks, and see ya.